Okay, the purpose of this video is to give you a quick um, overview of what Lesson 6 is about, and then kind of show you what the tasks look like, and also summarize it for you. So the first task is going to be kind of well, let me start with the learning target. In Lesson 5, we learned that you can find the area of a parallelogram by using the formula base times height. So if you can identify a base and a height for a parallelogram, you can multiply those two and you can always find the area of that parallelogram. So the first thing is kind of a warm-up activity on missing dots. How many dots do you see in the image? But more importantly, I'm curious, how do you see them? How do you see them when you figure out how many dots are in the image? 6.2 is going to be actually looking a little different. We're not going to use the applet. We're going to do that on paper. So it says find the area of each parallelogram, show your reasoning, and they just happen to be on the next page. So there's A, B, C, and D. So you'll need to find the base and the height, then you can multiply them. There's a little bit of challenge with each one of these. There's something a little different to think about. And then there's questions 2 and 3 that want you to think a little bit beyond. There's some challenging questions here as we're developing our understanding of parallelograms. Number 3 also uses this grid right here. You need to draw two parallelograms that are not rectangles with areas of 20 square units. So use this area to do that. So in summary, any corresponding pair of base and height can help us find the area of a parallelogram. However, some base and heights are just a lot more easily identified or easy to find. When we have grid paper like this, you can sometimes use like this right here, like if the horizontal line is drawn on the grid like that, we can use that as our base and then find the height like that. Or sometimes it's drawn vertically, that could be our base and we could use this for our height like that. Sometimes it's not on the grid, it might be a little tougher to find, but we can still see that 8 and 8 would both be my base and height because 8 meets this line down here at a 90-degree angle, and that's what we need to use. So regardless of what their shape is, a parallelogram that have the same base and the same height will always have the same area, because if you multiply their base and height, it's always going to be the same number. So here's an example here. If this has a base of 3 and a height of 4, the area is 12. It's a different looking parallelogram, different shape, but if it has a base of 3 and a height of 4, its area is 12. Same with this one that's rectangular, and same with this one that looks like that. That concludes the overview and the summary of Lesson 6.